Okay. Can you see the screen? Yeah. Okay.
It is working for me.
Beautiful. Okay, what else do I need to do? Fantastic. I don't need this. Oh, okay. Oh. Okay, so I guess it works.
Are you going to post the Etherpad link in the chat?
Yes, it's actually in agenda as well, I think, but yeah,
Post
you
it.
are
I'm on
right.
it.
Thank you. Switching the windows. Okay. Actually, I just realized 5 minutes ago that there are two other links. Other parts links. One is in the IETF site for Interim, among other materials and other stuff, and another one is Brian created. I think I have consistent. Yes, I think we have consistency on slides and agenda. Anyway,
It's a good start.
Yes. Anyway, basically, I think I put the same one on agenda on the slide. So I think it doesn't really matter because I will check both after the meeting. But
yeah. Let's keep the stuff in the one that's in the agenda.
yes. So yeah.
And that's the one that Brian just pasted into the chat.
Yes. No, I figured I'd paste the other one just to confuse the hell out of everyone. No, I pasted the one that we're using in the chat.
Brian, I don't know what year it is anymore.
I don't know what day it is anymore. My slide said 3rd of June, but I'm afraid I'm living in the future. It's 4th of June for me now. Actually, I don't know. Shall we start? Okay, slow start. All right.
Slow start.
Slow start.
I don't know if we were. Let's see.
By local time, right? So I will be very slow today. Okay. So
I would wait another minute at least for all of the people who are on our agenda as presenters to show up.
You see what's happening, right? Because I'm sharing my screen. I'm presenting. I have no idea what's going on.
Yep. That's why I'm here, Jen. I got your back.
Thanks, Brian.
You two are the best.
So we got.
I don't know.
We've got everybody in the agenda up to Spencer. And beyond Spencer, we are still waiting for a Gory.
Okay. Yeah, we'll be fine. I think we have a few minutes.
We have a little bit of slack in this, right?
Well,
not much.
Okay. Nobody's gonna kick us out of the room, right?
Sure, why not?
It's how it usually works at IETF, right? You see people open the door, trying to walk in. It's not going to be the case this time. So
exactly. I thought you were asking me to kick you out of the room. I can do that, but
no. And I know from previous interims that you can run over time and nothing happens, so they don't automatically shut down the meeting. They probably should actually, right? You should be on time. Okay, we can wait another minute. I don't know, 3 or 3.
I can talk slowly until Gory shows up. You're welcome.
I mean, we can also like we can do a slow start with my thing, right? So
Yeah, so I think we can probably slow start with welcoming everyone to the June 2020 interim pass-aware networking in the time of coronavirus. So, well, how can I do? Oh,
that's bigger.
yeah,
Mm.
yeah. So you see slides all right, yeah? So this is Note well. I do hope it's the right one because it's the same one Brian presented last time. I hope you've seen that before. If don't, please check it out. You know where to find the slides, right? Just in the case all links are in the agenda. So, I need to click recording, right? I guess because this is supposed to be recorded. Okay. Oh, it's already happening somehow. Wow.
Yep. Cool.
Good. So, how can I get rid of this? Okay. So, it's virtual interim. Please excuse me. I've never done that before. So let me remind you some special things about having virtual meeting. I was told that you having difficulties joining the audio by computer. Try call-in option from your phone. It's recommended to have your video off unless you have a funny head or something. Unless you're speaking, please mute your microphone. It does help. Webex chat is only to join the mic queue. Everything else should go to the Jabber room. To add yourself to the queue, press +Q, and Brian will kindly add you to the queue. And if you changed your mind and do not want to talk anymore, please put -Q in the chat. There is a virtual blue sheet. Agenda and those slides have the link. Please add your name and affiliation there so we know that you've been listening. And yeah, we have a session Jabber room. So, very important thing. Tommy is not joining us today, so we do not have a minutes taker. We need a volunteer. Please. I sent an email, but I have not got any response. So
this is your opportunity to write down what all the decisions are. Just saying. Maybe that motivates people.
Yeah, you can. It's a power, and the chairs will be very grateful. Please. I know that we have recording. So you probably can just listen to it later and put everything there, but
It'd be good to have notes.
yeah. Speech to text or something.
Let me look at the attendees in the Etherpad and pick a victim.
Yeah, you can volunteer someone, right?
Volunteer someone. Let's see, who could I volunteer here? Well, Spencer is an excellent minute taker, but he's also presenting some stuff, so that's probably not great. Lukas, could I ask you? And Lukas remains muted.
So he said yes?
No.
You can ask Brian, but my taking isn't very good.
Marwan said that he would be willing to do it if truly pressed. I think we are truly pressed, Marwan. I'll help you out. I'll back you up. Okay.
Yeah, I'll help Marwan as well.
Okay. Cool.
We're doing this in the Etherpad, right?
Direct in the Etherpad. That's why we got the so underneath each of the headings in the thing. Yep.
Yeah. Thank you. So we have actually fully packed agenda. So I don't know if anyone has any last minute suggestions or changes. 3, 2, 1, Sold? Okay.
So
So what's going on? Probably important announcement. We are inclined to change to virtual interims twice a year, right, Brian? And
twice a year, yep.
yeah, most likely not collocating it with IETF weeks, just something like what we're doing right now. So probably it will reduce some pressure time-wise from people. So be ready. Don't be surprised that you do not see PANRG sessions scheduled during virtual IETF. And we have 3 active research group documents we are going to discuss today and a number of interesting presentations. So the first on agenda is Brian. Brian, do you like me to open your draft or you like to present yourself?
Let me see if I can figure out how to present.
Oh, you need to drag something, but let me see if I can do that.
Hold on, reclaim host role. Let me do that. Oh, I don't have the host key. Okay.
I think I am a host, but let me assign control. Wait, make presenter. I can do that. I have all the power.
Excellent. I am now
Okay,
presenter, so I should be able to
you
share.
Yeah, you should be able
except
to
for right on this computer. I do not. Yeah, I can't actually show you the. So okay, here.
Okay, I will.
I will send you a link.
Okay.
We send you a link in the WebEx chat.
Okay, let me see where is it. Okay, chat. Okay, yeah, I actually. Okay, now I'm going to present your thing. Share. Yeah. Okay, you see it, right?
Yes.
Beautiful.
Hello everybody. Hold on. Actually, I should turn on the video because I was told that I should share video if I have a funny hat, which I do. So there we go. This is my PANRG hat, and it looks even sillier with the headphones on. So excellent.
Nice hat, dude.
Thank you, Spencer. So this is the ritual discussion of current open questions in path-aware networking, draft IRTF PANRG questions 04, where I ask the research group whether or not we should present this, and then I get either the answer yes, in which case we will publish this. So I'll either get the answer yes, in which case we will somehow fail to publish it, or I get the answer no, in which case we will keep it open and make a few minor changes to it until we have the next one of these meetings where we'll ask to publish it, and then we will say yes. So that seems to be the ritual that we're following. Jen, if you could scroll down to the diffs in the table of contents. There are no actual diffs in the table of contents, just page number changes. I just wanted to bring this up to show sort of what we think the questions are. There are 8 questions we think are open, having to do with vocabulary path properties, how you distribute them, supporting path selection, so on and so forth. After the last time we discussed this in Singapore, I got some feedback, I believe from Teresa, but I don't remember who, about making sure that the language and vocabulary of path properties actually covered the types of things we're thinking about in that vocabulary, which we'll talk about a little bit later. So if you can scroll down to the diffs in 2.1, I guess it's probably better if people actually want to read through these to go and actually have a look at the changes. This is the only substantive change to the document, and like the changes to the table of contents were just page number changes because this got larger. So this is essentially pointing out the issue that we have, that some things that we might think of like path and path element properties come with temporal scopes. This is dug into much more in much more detail in the path properties draft. And yeah, that's the, pointing out that temporal scope is part of the problem that we know that we need to solve here. So with that, basically, so each round we get, one or two minor comments. I would actually ask whether we can go ahead and say, hey, we have research group consensus out on the list. Obviously, to publish this is a snapshot, right? Like, so the 03 revision of this changed open questions in path-aware networking to current open questions in path-aware networking, putting a timestamp on it, which was 2019. Since the questions haven't changed since then, I think that's reasonable to keep that timestamp. And say, okay, we're going to take the snapshot at this point in time, and then maybe, do, once we've done a little bit more work in the space as a research group, to go do a retrospective. So that would be the question that I would ask. Does anyone have any comments on that?
This is Spencer.
Spencer.
I would just say, I think this is a good enough list of research questions for us to publish, to help guide the working group and to be able to explain to people who might not be participating as a research group, to explain to people who might not be participating in the research group now what the research questions are. So I think you could be through.
I think I'm through. I see a question from Teresa.
Yeah, I'm not sure if it's actually question or queue. So I would just say I also think we should publish this as a snapshot, and maybe we should do like a research group last call before we do so.
Okay. Yeah, that makes sense. Gory.
Hi, Brian. Scory here. I wonder whether we have to think a little bit about defaults and what we think is normal when we don't have a signal. Maybe that's part of the research question of untangling it, but it seems that as I look at paths, there's always some assumption about what you think is a normal path that is influencing the way you're using it or your design above it. So do we need to say anything about this, or is it partly implicit in answering each of the questions as we go through?
I would, personal opinion, I would think that that's a detail of each of the questions, and it's implicit in each of the questions that you need to have reasonable defaults, because it's one of those things that, we don't talk a lot in this document about implementability, because we think that implementability is actually one of those things that needs to be, kind of solved on its own. So I would, right, like, so if when you said defaults, I started looking at the document and thinking about how I would add, there need to be sensible defaults. And I would add, there need to be sensible defaults at least to sort of 2.1, 2.2, 2.3, 2.4, 2.7, right? Like, so I'd be happy to leave that implicit.
Yeah, I think I might be as well. I just wanted to ask, I guess we just need people to read all these things, which sounds like a working group must call. And we're in a research group, so a research group must call to read the document. Thank you, Brian.
You're welcome. Although I noticed that like this document's going to expire relatively soon. So actually I might, that point about implementability, I might add a sentence about, of course, if it's not implementable, it won't deploy, but, and implementation requires sensible defaults. So I might actually add a sentence based on that comment. Whether that's before or after we send it to a research group last call, I'll probably write the document just to make sure it doesn't expire during research group last call, because that makes the tools unhappy.
Okay.
Queue seems empty.
Cool. So thank you, Brian. So I guess here we've seen the new version, and then we'll initiate the last call, right?
I have homework. Excellent.
Okay.
Thank you.
Great. Okay. So next is vocabulary of the past properties, and let me get the slides. Okay. Work. So, hello, Teresa.
So, hi everyone. Maybe first of all, can you hear me well, or
I can hear you well. I don't know about the rest. Yeah.
So yeah, I guess I'll start my presentation then.
Yeah, so just tell me when to switch to the next slide. Yeah, I'm presenting.
Sure. So yeah, today I'll present the first version of the IRT draft of the vocabulary of path properties after the working group decided to adopt the document at the last meeting. Therese and I prepared this revision and we tried to incorporate as much feedback as possible from the last meeting and try to address most comments. So next slide, please. So the first change we did is in the terminology. So we didn't actually change the path definition, but we tried to make our idea of this path definition more clear. So what we try to highlight is that entities, like endpoints and entities in the network, might have different visibility of paths, but it might not see all the path elements, might only see a subpath or only a higher level. And also the entities might treat the path at different level of abstraction. So maybe a BGP router does not care about anything else than like yes level paths or this kind of stuff. And essentially what this boils down to is that a path can be a sequence of physical nodes, so a sequence of logical nodes, for example, a set of routers contained in a single AS, or it can be like specified up to the physical or link layer technology used, or just in kind of a logical sense, saying, well, this is just a path from a source to a destination, kind of in the way that current internet works, right? You have a source and destination and you don't know anything, or you don't have guarantees for anything between them. So yeah, we extended this definition to make it a bit more comprehensible, but we didn't actually change the definition of a path. Next slide, please. And then we added a new item to our terminology, which is a reverse path. We already had this, we already used this terminology throughout the document, but we didn't have like a separate item, so we decided to add it. It's simply a path that is used by the remote node in the context of bidirectional communication. So this is kind of a natural definition, and we already used it, so this is just to make it a bit more explicit. Next slide. And then we reworked the use case section. So here we mostly did structural changes and textual changes. So for the path selection, we did some small textual changes. And then we removed the performance monitoring and enhancement use case, since it seems that this use case was going too much in direction of internet measurements, actual path measurements, which is not what you want to show that path properties are useful for in this draft vocabulary of path properties. And then the traffic configuration use case, we split it into two use cases, namely protocol selection and service invocation, to kind of make it separate these two concepts, which are not exactly the same. So protocol selection simply states that an endpoint or a node network can select an appropriate protocol or configure protocol parameters given the path and its path parameters, path properties. And service invocation looks at entities that want to invoke additional functions that influence the path elements. So an example of this is using these zero RTT transport converters to allow a path or a subpath to use MPTCP or TCP. Next slide. And then we added two new path properties. The first one was also discussed in the last meeting, and is with transparency. And we decided to define this as a standalone path property, which is the definition as follows. So a node is transparent with respect to a protocol if it doesn't modify this protocol, any of its headers, and its processing is independent of any protocol headers. So, for example, an IP router is typically transparent to transport protocol, right? While a network address translation device looks at the transport protocol headers and actively modifies them. Another example is maybe kind of a firewall which doesn't modify like transport headers or contents, but it still looks at the transport headers and the application layer headers and to decide whether you should block or not.
So Gory, do you want to go ahead and ask now, or should we have one now, or do you want to wait to the end?
I'll wait to the end.
Okay, cool.
Okay, then I continue. And the next path property is kind of a logical follow-up from the reverse path. So we have a symmetric path, which simply states that two paths are symmetric if the path and its reverse path in the context of bidirectional communication consist of the same path elements but in reverse order. Okay, next slide. And then another discussion point during the last meeting was about security-related properties. So, for example, confidentiality or integrity. And Teresa and I, we thought about this, and we think we decided not to define additional path properties for these properties, or let's say confidentiality and integrity. Instead, we added one or two paragraphs in the security considerations section. The reason we're not sure if it's a good idea to add additional path properties right now is that it's quite difficult to characterize these properties. You need to consider a threat model, otherwise they don't really make sense. So you need to look at like the environment, different entities, and which protocols are used, what is its actual use case. And additionally, we think that the path properties that we defined so far in the draft and the security-related properties are orthogonal. So in a way, they're, of course, not completely, but kind of independent from each other. So typically, what the path should give you is connectivity, while the security-related properties are then just using this connectivity by using some protocol to establish, let's say, a secret channel. And I tried to illustrate this with these 2 bullet points. So you can say that path properties describe what function the network applies to the packets, while the security-related properties describe what function the communicating parties apply to packets. While it might be the case that not only the endpoints, but also path elements, let's say, are communicating, this is not the typical case. So I think I'm not sure if it's a good idea to make an additional path property for this. Okay, next slide. So then we had some minor modifications. So in the access technology, we emphasized more on the physical and link layer instead of saying, well, the first hop or the first few hops, since our path definition can be like maybe a different level of abstraction. It doesn't really restrict the scope so much as if you say it's physical and link layer technologies. And for the service function, we incorporated our new path property, which is symmetric paths, as an example for NATs, I think. network address translations. Okay. Next slide. So that's already the end of my presentation. So what we're mostly interested in is what you think about the transparency property and the new security considerations content, because that's the biggest change. The other changes are more textual and structural, or not really significant. So yeah, please, looking forward for your feedback.
So, Corey.
Hi. Well, I'll take a different question if I may. You've created a term reverse path and symmetric path. But you don't. But they seem to be based on routing exchanges, as in other words, it follows the same set of nodes, but the return path presumably can have its own properties, which can be entirely different to those of the forward path.
Yes. So symmetric path only means that that two paths, which are still independent, the forward and the backward path, that they are symmetric in the terms of which entities they traverse. It's true that properties could be completely different, but this is just to talk about this scenario, right? It's not, we don't make any assumptions that these paths should or must be symmetric or not symmetric.
Yeah, I don't know whether I like symmetric path yet, or whether I want to call it just symmetric rooted path, or something which kind of clarifies that there's no symmetry in the other parameters.
I was actually also not sure about this path property. The reverse path property, I think, is quite natural if you have bidirectional communication, but the symmetric path property is a bit can be tricky, I think, to define sometimes if you have like service functions and these kind of things.
Yeah, I mean, service functions don't require a symmetric path. They require that node sees the traffic in both directions. Is that not so?
Yeah, for example.
Yeah. So we've seen service functions deployed where the paths are very different in the forward and return directions, but they do pass through a single point of coordination or 2 points of coordinations which themselves talk with one another. So this is interesting to dig. I was only asking to make sure you thought about it. It wasn't a criticism. I like what you've done. I think we should carry on doing this. Thank you.
So I put myself in the queue. I also wanted to pick on slide 5. I was actually going to talk about so first of all, everything Gory said, I was going to mention that on the symmetry of the path. On the other side, there's sort of transparency. I would, in a former life, I did a whole lot of work on stuff that we called path transparency, and we defined it kind of like this. But in thinking about it, I would have made it a little bit more gray than this, right? Like, so here you say node's transparent if it doesn't modify the headers and it processes packets without looking at the headers. And there's sort of two different parts to that, and certain nodes will actually pull those two parts out, right? Like, so there would be you could have transparency in the sense of it might actually look at the headers without changing them, which will have certain implications for the types of protocols you can use on that path. And then there's one where it actually will try to change the headers, in which case it has other implications, right? So I would think that at the very least, transparency would be sort of like a 3-way as opposed to a Boolean. So, read only, read write, and doesn't use it at all. There might be more shades of gray than just those 3, but I would suggest considering at least having those 3.
Maybe now I think about it like a blocking. So these 3 is set plus 1 level, like it blocks or doesn't block.
Right. So for example, right, like, so an IP level router could actually look at the IP address, but it's not going to, if the IP address changes within the net blocks that router is going to put down that path, it's actually not going to change, right? Like, so it's, you can change the IP address, and if it's a router with a default route, it's still going to put it out the other port. Whereas if it's an IP address with NAT, it's also rewriting, which changes the semantics of those address spaces. So yeah, I think this is again, this is pretty much exactly when we started thinking about path transparency. This is pretty much exactly what how we defined it as well. But I would make it a little bit more nuanced here.
That's a very good idea.
Cool. Thanks. Spencer is next. Spencer.
Let me, well, not anymore. So I think a follow-on question to the previous two, which is, if you're talking about symmetric paths, are you talking about a path that is viewed as a symmetric path at the same level of abstraction in both directions?
I think you have to look at the same level of abstraction. Otherwise, the symmetry, I think, doesn't make. You could maybe say symmetric path, like subpath.
Yeah. Like I said, I was just asking a question of maybe not even asking for a change, but thank you.
And the queue is empty, going once, going twice.
Okay, thank you.
Thanks a lot.
Next, Spencer.
Okay.
Okay, the floor is yours.
Excellent. So I'm also wearing a cool hat. So talking about the path-aware networking obstacles deployment draft, dash 08, and could you advance that to the next slide? So basically, these are the changes that we've done since IETF 106, which is the last time we talked about this. We were doing research group last call in December and got good comments from Teresa and from Michael Scharf helping me respond to Teresa's review, and then from Med. And then I finally noticed that I'd misspelled Olivier's first name in the first paragraph of the draft, like seriously, but sorry. But that's what's happened since IETF 106. We could be finished, but are we? And could I get the next slide, please? So the question about what is path-aware networking anyway, I got this call more than a couple of times, especially at last call. I've seen that comment on other PANRG docs. I added something that might not be completely wrong in -06, section 2. I have no reason to believe that most of the research group even noticed it, and the draft was adopted by the research group. So that's probably not good. So let's talk about what path-aware networking actually is. Next slide, please. So this is the text that I put in as 1.2. Do people need a moment to look at it? Not hearing anyone say no.
You hear us reading?
I can hear the brains chugging.
Yeah, this looks perfectly reasonable to me.
Okay, so next slide, please. Everyone, please step away from the mute button. We'll talk about this in a minute. Next slide, please. So the questions draft has some description of path-aware internet networking architecture that talks about two important properties and what that is. And there's more in the introduction, but you kind of get the idea. Like I say, you can check that out on the -4 revision of the questions draft. Next slide, please. And the path properties draft basically defers to the questions draft. We have at least a couple of competing definitions in the research group drafts. The next slide, please. So my point is that I'm not sure we have a canonical definition of PAN now. It could be the one in PANRG questions, although that seemed a bit more about architecture than PAN itself. I had the question of whether we needed a canonical definition, and we could talk about that on the PANRG mailing list if what it would be, but just to get a feedback from in person whether this is helpful or not, and also where to put it. What not to do is a horrible place for it. So I'd love to be deferring to a draft that is not bad ideas. And no, that's not right. I would like to defer to a draft that is not about ideas that didn't receive deployment. The path properties could work, and then point to that. But maybe there's a better place, but we can talk. Next slide, please. So thoughts?
Yeah.
Yeah, that one, absolutely.
So I put myself in the queue first, but I'll actually let Teresa go first because hogging the queue as the queue manager is terrible, terrible practice.
Okay. So I think, yes, we should have like a definition. I think the questions draft is a good place for it. That's why I linked to it in the path properties draft, but it should probably be a little bit expanded. Or there was also in one of the reviews that we got from Matt on the path properties draft, he asked if maybe we should have like an entire architecture draft about the architectural assumptions that we made in the path properties draft, and then we dialed back the assumptions a little bit, but still there's some kind of like architectural understanding. I don't think it's enough for an entire draft, so I think it might go in the questions draft. I don't think it goes in the path properties draft.
Cool.
Okay, so that's me then. Hold on, let me think about that for a second. Right, I am unmuted. So actually, could you go back to your last slide? Jen, can you go back one? Yeah. Do we need a canonical definition? My personal take on this is no, we don't, or at least not like a succinct canonical definition, because if you look at the questions in the questions draft, they sort of lay out a space for research. And if you look at essentially the attempts to answer similar questions or related questions in what not to do, none of them are really phrased in the same way as the questions in the questions draft. So I would say that, I mean, to the extent that we need the canonical, a canonical definition, we can actually make the canonical definition be the entire text of the questions draft, right? Like, so these are the types of things we are interested in, but I explicitly don't want to prejudice any sort of like, it has to fit into this particular projection of this particular
Right.
descriptive architecture in order to fit here, right? I understand why reviewers would be confused about this, right? Because it's like, this is amorphous and it's purposely amorphous. I think the idea of an architecture draft makes sense only to the extent that it gives people who really, really want to have an architecture draft something to chew on. I think it should, if that draft's normative language is longer than its boilerplate, then that's a failure. Whether that should be like a section of questions just to avoid having to take another draft through the process, or because I mean, like, it's literally like a paragraph, or whether it should be in, its own one paragraph draft. I don't really have an opinion. But in general, I would say that like the need for a canonical definition or the need for a prescriptive architecture for path-aware networks at this point primarily just is there to give people an unsatisfying answer to a question they feel like they really need to ask. And I'm not sure whether that's, I mean, on the other hand, it's not a lot of effort, so it's certainly worth the effort to address. I would be fine adding a one paragraph section to questions to handle that.
Okay, so
go ahead, Spencer, and then I have Teresa and Gory.
To the best of my knowledge, you and I have never been awake at the same time talking about both of our drafts on the definition, because I've added it since the last IETF meeting that we met at in person.
No, we have not. Yes.
So one thing that we could do is have the two of us chat and come up with something maybe merged out of what I had, I should have said this, was kind of taken from some of the text in the charter.
Mm-hmm.
So for you and me to come up with a proposal, put it in the questions draft, and I can point to the questions draft in my draft.
That seems perfectly reasonable. One thing I wanted to say that I forgot before I started on my thing there is basically I don't see. So you're pointing out that we have three definitions that differ from each other very slightly in sort of their wording, and people who really want to language lawyer it could actually see that implies a difference in scope. I don't. I think all three of those are perfectly compatible with each other, and I don't think that there's a scope problem. But that's maybe because I purposefully want to keep this amorphous for the time being. So I think the overlap of all three is fine. I think, yeah, like if we just sit down and try to be awake at the same time for like a couple of minutes, maybe bring Teresa and Cyril into that as well, which makes the awakeness slightly like 2 times as more difficult. But yeah, we can deal with it. I'm good at -9.
It's getting easier.
Yeah. So yeah, that seems like a perfectly reasonable thing to do.
So the other thing I wanted to mention, because I use the word canonical probably inadvisedly. That's what you would want, but you're supposed to say that when I'm wrong. But this being a research group, things that don't fit the canonical definition can still be interesting to a research group.
Yep.
Where that's not true for an IETF working group.
Yep.
So for us to not think of it as a canonical definition, but just kind of, here's what we think is going on in a general way, and to have one place where we point to that says, here's what we think is going on.
That seems reasonable. I mean, just to answer the question, that seems reasonable. Teresa.
Yeah, I agree with what was said, that we maybe don't need the canonical definition. I was also just, I thought we should also make sure our charter reflects our scope, right? Yeah, because our charter also explains what path-aware networking is.
Yeah. Counting the charter, we actually have 3.5 places where this is described.
So we have more definitions than we have documents, which is awesome. All right. Yeah, we need to clean this up.
Excellent.
So Teresa, you and Cyril, would you like to be in on whatever call we pull together? Cool.
And we'll propose the results to the research group. Excellent.
Yeah, Gory, do you want to be in on that call?
I could be. I have something to say, because when we publish documents in TSBWG in the IETF, there are always people come and try and beat me up saying that transport's end to end. Full stop. and I think it's important to have some text that kind of explains the path is at the core of all this stuff. And Spencer's text looked okay, but I think we need to agree on some words. I hated one word in Spencer's text, which was a word "the" or "the" before something.
This is what happens when you get IETF people writing IRTF documents. My apologies.
Sure. But generally, I liked it. So, and I think it's useful. So I go with everything everyone else has said, and I won't say more. But yes, I'll happily talk about it with people if they want to have another mind. I'm happy.
Cool.
Fabulous. So, could I maybe, is the queue empty? I'm sorry. I think it is.
Yeah, the queue is empty.
Okay, cool.
Keep on keeping on.
If you want to do the next slide, please. And then the one after that. So I think we know what to do with that question about the generally what's going on, global definition. So that's good. Thank you all for your help with that. On behalf of all of the authors and charter editors. And could I get 2 more slides back? You can skip the next one. That would, no, sorry, I'm
This
sorry.
one?
2 more slides forward. I'm sorry.
Forward. Okay.
Yeah, okay, yeah, this one here. I mentioned this at 106, but the goals for this informational draft were to inform research in this research group, which is fine that it's still a draft in the research group, research outside this research group, and engineering outside this research group. And it seems to me that we need to publish in order to inform activity outside the research group. This morning I'm being recruited to help with another buff that is in this space, the IETF, and I would love to be able to provide information to engineering that's happening outside this research group, which is one of the most valuable things I think we could do with this draft. So questions, are we finished yet? And if not, what else do we need to do? We've said that it would be great if we were came up with a one general idea of what we're trying to do. And that's good. Is there anything else that we need to do with this draft before requesting publication?
So I will throw myself in the queue and say, I think we're done modulo whatever tiny changes you want to make to the language based on our where the definition goes thing. But
yeah, and I think my definition will be ripping out everything that's not pointing to the one true general idea.
Yep. The one true you do what you want. Okay, cool.
Cool. Anything else?
So is that like with chair hat on, that is a request that the next revision of the doc gets research group last called?
The last version was research group last called.
Oh, right. Okay. So then the next version gets sent.
Excellent. Fabulous. So,
Teresa, that was a +1, not a +Q. That was 1 key off, correct?
Yes, it was a +1. I agree what you were saying.
Just making sure we're not running over you there. Cool.
Cool. So I think I'm on next also, am I not?
You are on next.
Yeah, you're on next. Let me get the slides.
I will observe we're doing pretty good on time right now. So I would actually say that if we end up at the end of this with any time available, we should just make that call with those of us who are going to bang out the next version of this, just be like at the end of this interim meeting, and we should just, anyone who wants to be part of that discussion should just stay.
Cool.
Since we're already all here and awake to some extent.
Okay. So you have me going now?
Go for it.
Nobody said I was
Yeah.
awake, right? But so the other thing that I was asking to talk about, and this is not something that's gotten a lot of work of mailing list attention yet. So thank you all for putting this on the agenda. But whether there were design goals for path-aware networking, which knowing what we're generally trying to do would probably help that idea also. Next slide, please. So if my thing is basically, if somebody proposes my great path-aware networking approach, how do we know it's a good approach? That maybe we should have design goals. We have the idea of a beautiful baby contest, where you line up all the beautiful babies and see which one is the most beautiful baby. And if you don't agree on the definition of beautiful before the babies arrive, you have to tell people that their babies are ugly. That seems wrong to me. Next slide, please. So question, do we already have design goals for PANRG? We learned a lot in what not to do in section 2 and section 3. Number one, we did not have very many filters for adding contributions to section 5. I believe the only filter we used was that we were including protocols that had gone through IETF standardization at least part of the way. And some of those contributions dated back to the 1970s. Some of the goals have been dumped. We learned a lot, but the entire draft was backward facing. And I think there are some things to think about in the future that were not impediments to deployment in the past, like privacy, but probably are design goals now. I'm curious about what else would be new. So if people wanted to jump in the queue for that in a minute, or if you want to jump in the queue now for a discussion about that in a minute, that could be great. And it seems to me that agreeing on design goals would help us provide a document on what to do. We've been asked for that repeatedly, and maybe we could provide that. Next slide, please. I wanted to talk about this for a second because this was a little bit the model that I was thinking about, and I was not the person that suggested this, but someone smarter than I did. The research routing group came up with a design goals for scalable internet routing and published it as an RFC, which was a prioritized list of design goals for the target architecture. They started with RFC 1958, so this is the Internet Architectural Principles. They set out a bunch of design goals for the future. They're all short. I don't think any of them are page long. Probably the average is about half a page. And then they provided a summary of the design goals. So that was what was in 6227. Next slide, please. The question is something like that a good model? It seems to me that agreeing on what we're trying to accomplish would help us. We won't all have the same goals and no other goals. And this is different from RRG. There's only one internet to do internet routing on, but there could be lots of different kinds of PANs. So this may be more of a list, a intersection list than a union list rather than a intersection list. It seems to me that we could continue discussion about this on the mailing list, but since we're all here together now, we could talk. I think that maybe, is that my last slide?
Yes.
Yeah, cool. Excellent. So please discuss.
So I'm actually just in the interest of fairness going to keep my position in the queue before Teresa this time. So like that sound of the scrolling in the background is those of us who didn't see your slides before reading 6227 as fast as we possibly can. And like I was looking at that was, includes me. I was also looking at 6227, and I noticed that like some of the ways that some of these goals are phrased are kind of along sort of like subpoints in the text in the questions draft, right? I would think the design goals for a path-aware network is basically you need to solve 2.2 and 2.3, so discovery, distribution, and trustworthiness of properties, and way to do path selection. the interfaces for path awareness are something that you need to actually deploy it. Like you actually need to be able to write programs that use it, right? And then the rest of them are kind of like higher order sort of requirements to get it deployed. So I think that if you basically take question 2.2 and 2.3 and tear them apart, that turns into the beginning of the design goals for path-aware networking. And that might, we might actually want to have that as a separate document, because I don't want to stuff design goals into a questions draft, right?
Right. And let me say, and can I agree? Do you want to keep talking, or do you want me to agree with you now?
Well, let me keep talking, because I think you're going to disagree with the next thing I'm going to say. So I'm actually looking at 6227, and to some extent, the reasons that people care about path-aware networking are some of the design goals for the new routing architecture as well, right? Like, so one of the path-aware architectures that actually seen some implementation and pilot deployment is Scion, and one of the big goals of Scion is routing scalability, right? Like, so actually fixing the problem of needing gigantic piles of TCAM all over the network by actually pushing that to the edge. Scalable support for traffic engineering. So endpoint traffic engineering is essentially QoS, right? Like, so the difference between traffic engineering and QoS is who's making the decisions. And that is also like a key goal. Scalable support for multi-homing, that's also a key goal. Like, I mean, we could almost, it struck me a little bit, how much of the design goals from the routing area from when was 6227? This was 2011, a decade ago, are basically design goals that we still have for PANRG or for path-aware networking, because they're the same problems that we have with the current internet. So I think we have to, like, we don't, if you look back at 6227, of all of the things on this list, the only thing that came through the IETF process and saw any kind of sort of implementation, I'm not sure about deployment, is the decoupling location identification with Lisp, right?
Yeah.
The rest of it, to the extent that those problems are solved, like, so scalable support for mobility is solved by architectures outside of the IETF and outside of the internet, sort of the internet protocol stack. So I would use 6227 a little bit as, maybe a pattern in terms of it's got the same boilerplate on it and the same general document structure. But what I look at when I see these 11 points is an attempt to boil the ocean. And we're trying to do the same thing in PANRG, right? So, like, let's change the space of architectures that we can deploy in the internet. That's a different ocean to boil. But I'd be cautious about, like, trying to solve all of the problems at once, because all these problems are the same problems that we care about, right?
Right. So let me rave for a minute, and I'm not going to disagree with you much. The first thing I was going to say was you're looking at the you were looking at the questions in the questions draft, and I would suggest sprinkling stuff out of what we learned in section 2 and section 3 out of what not to do. Because there are, there is, we were doing work there too that was going to drive the things that we still need to do and that we think matter and things like that. So I think that throwing those both up in the air and picking up the pieces could be a really good way to get started. I think that I agree with you on the boil the ocean nature of 6227, and I think the other thing was, if you go back and look at where the RRG came from, and I was paying some attention to this, but there are probably even people on this call that know more. My recollection was that this was that internet routing is going to die very soon in the 2006, 2007, whatever the IAB workshop was on internet routing. But you know, they were kind of more under the gun for fixing internet routing than maybe we are for solving all the problems of PANRG. So,
Right, but I would notice that workshop was basically, I mean, it was about like a perceived pending emergency in the size of the routing table, and the design
exactly.
goals ended up being 11 points long. Whereas it's really the first design goal was the reason that they showed up, and it's like, well, if we're going to mess with it, we might as well mess with it a whole lot. And you know, I'm afraid we're kind of doing the same thing here, but at the same time, I'm a little bit afraid that, well, no, I think it's a good exercise, sort of like take sections 2 and 3 of what not to do, accelerate them to a very high speed, and slam them at that high speed into sections 2.2 and 2.3 of questions. And it might be that they annihilate each other, and we just don't know what to do, right? Like, so we know what not to do, but what to do is still up in the air. But I think that actually sort of like sitting down and trying to tease that out is also one of those things that I really wish that we could actually get on airplanes and get in a room, because that's one of those things that like an actual physical whiteboard would be super useful for.
You're still very close to a supercollider, aren't you?
Yeah, every so often, like all the stuff on my desk shifts toward Geneva. It's kind of scary.
I get that. Yeah.
We're getting loopy. So let's Teresa.
Yeah, so when I read Spencer's email in January, I think, which I think I asked this question first, I thought that the problem statement for scalable routing might be a little more narrow than our problem statement for PANRG. I mean, I don't think we really have a unified problem statement. We were actually just discussing that, right? That we kind of, whether we need a unified definition. So how to solve the questions in the questions draft might also depend on your specific problem statement and your specific use case. And then maybe there could be trade-offs between like different design goals. And so I was wondering if maybe a good place to, or an interesting place to start would be to try to identify existing path-aware technologies that were already successfully or semi-successfully deployed and analyze what they did right, and then sort of map out a space of different specific problem statements where people use path-aware technology, and then have this be a sort of what to do instead after the what not to do draft, right? So that's just some idea I had. And I also put that down in an email in reply to Spencer in like January, if you go back and read the mailing list.
So I remember that, and I think that's what I was thinking about when I was thinking about whether this was the same thing or not. But I agree that it's not. So yes, this is not the same as the PAN problem domain is not constrained the way the routing research group problem domain was constrained. But yeah, I mean, the other thing was, the idea is that this is at least theoretically going to drive work in the IETF very soon, and this may not be as under the gun as the routing table explosion was. Next.
Colin.
I get perhaps a little nervous when you start talking about design goals, because that to me suggests that you're trying to design a thing or a single architecture, and I'm not sure we're quite there yet.
I agree. Yeah.
So I'm not sure what the right term might be instead. Design principles, maybe, or guidelines, or I don't know. But I would caution against tightening things down in a way that funnels things onto one architecture at this stage, until we better understand the problem space.
If I was going to try to make a Band-Aid fix, I might suggest doing something that was some design goals. Because, you know, as we're saying, whatever we're doing is not going to apply to all the PANs everywhere for all time anyway. So,
Yeah. And I suspect we might end up with some quite different path-aware architectures that have very different goals, but share some core principles in common.
yeah, that would be a very helpful observation for us to outline a document like this. You know, what's a principle and what's something else.
Yeah. How different can a path-aware networking architecture be, but still fit into the scope of things we're talking about?
Yeah. And this being the IRTF, that's, you know, the scope is broad but not infinite, but it is broad. So
Exactly.
definitely agreeing. Thank you.
Russ.
So I think the situation in this research group and the RRG are quite different.
Yes.
There we had one group of people who thought the internet was about to melt down through the explosion of the routing table, and another group within the research group saying, keep calm, there's things coming along that are going to make this okay, and trying to create the document that you were just pointing to was kind of the prioritization in it was one of the mechanisms that they use to keep from killing each other, I guess. But I think we have a very different goal here, which is if we can do something to implement a PAN, what are the benefits to the applications that use it? And so I think that would be more helpful to people who are working on this than especially an ordered list, but even a collected list of goals that are sometimes don't even fit well into the same puzzle because they're somewhat orthogonal or trying to approach different aspects of the reason you want path awareness.
Yeah, I think this is what happens when you take puzzle pieces and try to use them as Legos. I think you're right, exactly right, Russ. And I did have confidence that somebody on the call would know a lot more about the RRG, the RRG document history than I do.
Well, that was exploding while I was IETF chair.
Russ, everything exploded while you were IETF chair. But thank you.
So I was in queue, but we're out of time. I'll take it to the discussion after. It seems like there's definitely some appetite to try and do something here to not like bolt it down too hard. And we'll take that back out to the list and I guess continue that thread from January.
Sounds like a deal. Thank you. And we'll try to do the right thing.
Sounds good. Next up is Gory.
Yes. Yeah, let me get the slides. Okay.
Okay. Can you hear me?
Yeah.
Okay, so this set of slides is related to the discussion we've been having in ETOSAT. It's very much about paths. It's only a little bit about path-aware networking because at the moment we're not quite there. And you'll figure that out as we go through because maybe the solution is path-aware networking for many of the problems we have. I'm going to be talking about paths that have a high bandwidth delay product, particularly paths where the return or reverse path is asymmetric, so it is different to the forward path. And I'm basing this on some spreadsheet analysis and part of a set of data we've collected using a test bed, looking at quickly Chromium and some performance of TCP using Reno. Right, next slide. Okay, basic message here is forward paths are not the same as return paths for many people. Return paths are not all the same. So we're going to focus on the return path for the moment. Return paths for many protocols mainly just carry ACKs. They're just small packets sent occasionally. Do they matter? Yeah, they do. If you've got a gigabit per second, then you're probably about 5,000 ACKs per second crossing that gigabit infrastructure in the return direction. And different types of return path have different properties. Some of them are a bit congested. In other words, they have capacity limits or some form of contention ratio, which limits the capacity by time of day or other users, or they are limited by the packet rate they can support. Many of the technologies we have out there in the real world are asymmetric because return packets actually consume a lot more resource than forward packets. So it's important to look at this stuff. Next slide. In Spencer's vein, let's go back into history and find out what happened. We have TCP. TCP designed with a ratio of 1:1 originally. That used 3% of the capacity in the reverse direction simply for carrying ACKs. And everybody agreed that was far too much. So TCP ACKs every other segment, or is recommended to ACK every other segment, overhead about 1.5% of the traffic devoted to ACKs. Actually, that's still too much for many deployed infrastructures. And if you actually do an analysis of network traffic, you'll find that stretch ACKs are common with 1 ACK every 3 or 1 ACK every 4 packets. Many of these thinned packets are generated by offload cards that reduce the number of ACKs, or they're generated by thinning in the network. Thinning is widely used to get down to less than 1% of the forward capacity. So that's, the top line of this chart from TCP is just a statement of the current state of the art. Along comes QUIC. QUIC uses 1200 byte packets. And you can see immediately in comparison, QUIC takes a lot more capacity, roughly twice as much as TCP. And QUIC's been specified to use an ACK for every 2 ACK eliciting packets. So it consumes about 3% of the return capacity. Much more than 1, which is the target for many operators. And this could be due to the fact that QUIC uses 1200 byte packets. So what happens if you use 1500 bytes? Well, it's a little bit better. It goes down to about 2.3%, but still way bigger than 1%. So we wrote a draft about thinning ACKs to 1 to 10 in the network. In other words, just basically changing the ACK response of the QUIC client so that when it receives 10 packets, it will send 1 ACK rather than every other packet it receives. Next slide. And we had a scenario to look at. And because the ETOSAT mailing list is all about satellites, we use the QUIC for SAT architecture. And we looked at a number of scenarios. 10 megabit forward with a 2 megabit return, which is a 1 to 5 capacity asymmetry. 10 megabit forward with a 0.1 return, which is a 1 to 100 capacity asymmetry. And we also looked at 50 megabits with 10 megabit return and 50 megabits with 0.5 megabit return. These numbers are not actually that uncommon. DSL has an asymmetry of about 1 to 8. And I think many people who use cable modems experience sort of asymmetry, perhaps 1 in 20, 1 in 40 capacity asymmetry. This sort of asymmetry is very common both in the satellite world and outside of the satellite world. And ACK thinning is a commonly deployed method used in all of these, and also in Wi-Fi drivers. Standard Wi-Fi drivers that you see for Wi-Fi chipsets implement a form of ACK thinning. So, next slide, please. Let's have a look at how this generation of ACKs in TCP is affected by these asymmetry scenarios that I've just proposed. So looking at the performance of TCP, with a 10 megabit forward link and a 2 megabit reverse direction path, you can fill that path with 10 megabits per second of traffic. It actually consumes 16% of the return path, transmitting just ACKs, which is okay. If the asymmetry grows from 1 in 5 to say 1 in 100, which is the 10.1 scenario, then TCP's forward data rate becomes limited completely by the amount of ACKs that can be returned across the path. It goes down to 3 megabits per second with a 1-to-1 ACK, 1 to 2, the default for TCP. It goes down to 6 megabits. It's limited by this. And you can see this is the motivation for ACK thinning. The red boxes display places that are limited by the return rate of the traffic on the path. In the non-red boxes, I've shown in percentage the amount of capacity consumed. And some of these numbers are a basis for concern. The packets just carrying ACKs can consume quite a lot of capacity. And nowadays, we tend to worry about capacity in the return direction, perhaps more than we used to. People are doing more uploads since they're working at home. Many people are doing like we are. They're using video. I'm setting video on my return path. And fitting that into the capacity pool is creating real pressure on this infrastructure. Quick, as currently designed, is not helping this at all. Let's go forward one slide. Next slide. Yeah. Basically, too much ACK traffic is not helping the transport protocol, but it's squeezing out other traffic on the return link. And this is a real problem. Go to the next slide. I'll show you what the effect is on the traffic. So real data, real tests showing Chromium traffic. And you can see here a set of lines that show the packet rate on the vertical axis against time on the horizontal axis. I will look first at the blue line, which is Chromium using the ACK ratio 1 to 2. And you can see that it grows its rate exponentially up to about 5 seconds, and then it transmits stably, filling the forward capacity of the link. This is for an 8.5, 1.5 link, so 8.5 megabits forward, 1.5 return, and the quick flow achieves 8.4 megabits per second. If you keep the ACK ratio 1 to 2 as specified in quick, and then you reduce the return capacity to 100 kilobits, so you have a capacity which is now constrained 1 to 100 ratio, the forward rate is significantly reduced, down to 5 megabits in this case. This is BBR data. If you know BBR, you'll recognize the rather stable response. You'll also see that the red line slopes slightly upwards for some bizarre reason, which maybe you could explore in ICCRG and ask them why, because it doesn't seem right, but it is the way BBR works. What happens if you change the ACK ratio? If you change the ACK ratio, quick changes the behavior back to the original. So the black line is almost coincident with the blue line. The forward path is completely filled, and the return path for this traffic. It's a stable situation. It works okay. And the default mode in Chromium is actually to do this change dynamically, moving from the ACK ratio 2 after 100 packets down to the ACK ratio 10. But that's not what the IETF quick working groups currently picked up on. Next slide, please. This is the result with Reno. Maybe you thought that Chromium was using BBR and that was the reason why it worked. Well, it certainly worked smoother with Chromium, but even if we just look at Reno, and we look in this case at the return path, you can see that the ACKs follow more or less the behavior you would expect. TCP has a certain number of ACKs per second. Quick, with an ACK ratio 1 to 2, has a similar number of ACKs per second, which is what you'd expect. However, the ACKs are bigger, so they still consume more capacity. If you thin TCP ACKs, they reduce. And if you use an ACK ratio 1 to 10, then you get a performance where the ACK ratio is reduced, of course. So this is really showing what you would expect. So while I'm doing this, let's look at some other type of data. Next slide shows the results for bulk downloads. This is bulk download of 100 megabytes of data. You can see the download here for a 50 megabit path. So it's using a higher speed forward link, and we get 28 megabits per second out of quick by default. Maybe we would get more if we tuned the flow control more. There is a limit here. Immediately, you move to a higher asymmetry. In the 50.5 case, you can see that the capacity has been limited, the forward rate has reduced, and therefore the time to complete has increased, and the overall throughput becomes 18 megabits rather than 28 megabits. The same message. Basically, your path is being constrained by the return link acts. So return link acts do matter, and we have access to ACK thinning on the path. What can we do? Next slide, please. Well, the first thing is we could find out what's on the path. So we had path awareness, and we discovered that there was something on the path with a certain ACK rate or a certain capacity limit. We could adjust our transport in response and respond to that. I mean, that's a good thing to do, and that's a thing that we'd love to see emerge from path awareness. You find out what's on your path and you adjust to it. Unfortunately, this is a luxury where you don't have at the moment. Basically, people sit using their laptops, using whatever network infrastructure they have, and they don't really know how that's operating or what the constraints are. So the transports can't figure this out. But they can figure out when they want to reduce for other reasons. I mean, there are other reasons why you might want to change the ACK pattern. And these are purely transport related, not path related. For instance, to reduce the interrupt rate on your device, your server device, or because you've got another congestion controller that's, doesn't need an ACK frequently, maybe only needs one in every 100 packets. So there are good reasons why you might want to choose very big ACK ratios, but I think these are all defined by the transport operations. Jana has a draft in the quick working group that looks at this aspect. It doesn't really solve my problem that I started with, which is how to deal with a path that is naturally very asymmetric, because you wouldn't know to adapt. Can I go to the next slide?
Okay.
Yeah, oh, thank you. So, ACK traffic is still a lot because it's using a 1:2 ACK ratio. What happens when this traffic is injected on the paths that we've been speaking about? Well, a link can't see inside a quick packet. It's not aware of the contents because it's encrypted. So a queue builds in the router becomes congested, and we end up with a delay and a rate limit, which is what we saw evidence of. If we looked at the delay, we see the delay creeping up as well. The solution to this could be deploy some form of AQM, use a shorter queue to control the delay, simply resulting in higher ACK loss due to router queuing. We'd also lose some non-ACK frames, which probably will have some impact on the transport, in this case quick, but it's the best a router can do. Perhaps some sort of queuing might help within the device to stop you deleting packets from other flows that really disrupt a different flow, causing collateral damage. And that also will have implications for queuings not without its own costs. So I'm motivating that choosing the right default would save a lot of mess. If you don't know how to set that default because you don't have a signal from the path, then you have to choose a number, and you have to choose that number wisely. 1 to 10 appears to be a number that works consistently with what has been deployed for TCP. So next slide. Here's my question slide. I'm more than happy to take questions on this. We have a number of slides that are related to this and similar topics, and we'll be talking about these on the EtherSat mailing list. So if you want to talk a lot about it, please join that mailing list. I'll take questions now and be happy to try and answer them.
Going once. Going twice. I guess we will see you all on the EtherSat mailing list. Thanks a lot, Corey.
Yeah, see you there.
That was fascinating. Thanks for that.
Okay, John.
Can you hear me? Okay, I'm going to
Yeah.
keep
Can
this
indeed.
pretty quick because this is actually a follow-up to earlier data where I just wanted to add in the error rate measurements. Next page, please. So, the problem statement is similar to what Corey was talking about for different reasons. The TCP transport protocols don't perform well over high latency links, particularly with respect to error recovery. We generally have always used TCP spoofing. Can't do that with any encrypted transport particularly quick. Next page. So we set out to try to measure how bad the performance was. This is with Google Quick, because that's what's a bit, what we see in our network. This is really our test drive. You can come back and read this if you want to. Next page. So there was two test setups, one where we went through our own equipment to test the path with PEP, and one where we just let it go directly through and RQuit was not involved to compare. So basically that gives us both spoofed and non-spoofed TCP as part of the comparison. But the delay it added in both cases was the same. Next page. So we did some different testing variants, two versions of HTTP and 1 gigabit connection. We did 3 file sizes. I'm only going to talk about one of them because the answers were essentially consistent. So 1 gigabyte files, and then we tried 3 different packet loss rates. We actually tried 4. We tried 10% loss. That was so bad we didn't have time to figure out what was going on, and so we just kind of dropped that from the point of view of this paper we were writing. Next page, please. This is what I'm going to talk about. So here are the results. With no packet loss, spoofing could go really fast on our 250 meg link. The HP 2.0 was limited by the Chromium, I think. And so originally, this is what my last presentation was about. Comparatively quick, which you can't do a spoof on. The speed is slower because you got to do the end-to-end latency. But particular interest for right now, why I wanted to present again, is when we tried the packet loss rates, you could see that the packet loss, of course, as expected, reduces the throughput for all 3. The PEP one kind of compensates, which is what it's designed to do. Without PEP, though, it starts dropping down significantly. And of course, the reason being that when you drop something, you've got to recover it with this end-to-end delay. The part of what we were motivated, part of it was to talk about other error recovery scenarios. I was looking at loops-like things and stuff within Quick to do FEC and things like that. But also there's some path-aware stuff. Next page, please. Well, that's the next presentation, I guess. But anyway, the rest of this stuff is the graphs. So I'm trying to keep this fast. So basically, I'm done, and if anybody has any questions. I'm also trying to go fast to give Nicholas more time on his.
So I'll ask one super quick question. If you can go back one slide. So I find this really interesting because there's like sort of basically two things you're testing here. Is one, the the effect of the PEP, which of course doesn't work on Quick, and would need some modifications to sort of the PEP and to Quick in order to make that work, which I guess is why this is interesting for this group. The other thing that I find really interesting from this is if you go to the direct path numbers, so Quick is actually operating as intended, right? Like, so it's part of its value proposition is that it does really well on exceptionally crappy networks if there's nothing to accelerate out of the way. So I think part of the issue in terms of like talking about Quick performance with, so in the Quick working group, the Quick working group is doing all of their testing based on sort of the right set of tables here, right? So they see, hey, there's no PEP because we don't have one. We're not going to implement one. We do better than TCP with no PEP on this ridiculous link. Whereas, yeah, so it'd be interesting. I don't know. It'd be interesting to maybe get this, get these numbers in front of the Quick working group. Well, at least those of them who are not here. I think there are a few Quick people I see in the.
Yeah, we've talked about this on Edosat also. Yeah, I mean, if you just look at the right side, I mean, Quick looks pretty good. It's doing better than TCP. From our perspective, of course, we sell satellite networks, so we want Quick to be on par with a PEP TCP. So that's where we're coming from. And so basically, we know we can't PEP Quick, so we want to improve Quick to get up to these numbers. And the key part being, of course, how do we recover from errors? But I agree with you on the right side. I mean, even with this delay, Quick is still outperforming TCP when you don't have a PEP.
So, Gory?
Yeah, I was wondering, John, are you going to go back and do some more measurements? Because these look really cool, but they're not quite the latest Quick. It might be slightly better now.
Well, that's a good point, and we actually are in the process of staging up an internet, an IETF version of Quick with an H2O server and getting ready to redo all these tests, as well as some more tests related to smaller interactive traffic, which is related to the next topic I want to talk about, which is classification, coming up in a couple presentations. But yes, we're definitely continuously testing this.
Going once, going twice.
Wait. I'm still trying to figure out how to drag my chat down so that I can type in it. Sorry. 3 monitors, first teleconference like that. Where do you want additional discussion to take place on this?
Well, for right now, we've been using the Edisat list. At some point, we wanted to move over to Quick itself, but we were intentionally kind of staying out of the way of getting the first documents done. But since we're getting rid of
Sure. Yeah.
I kind of didn't want to go over there until I had more concrete proposals.
Yeah, sure. And like I said, I didn't have an opinion about what the right answer was. I just wanted to make sure that I knew where to look. And related thing, so you're standing up basically to be able to test bed with dash 28 or whatever we're doing in Quick protocols now.
Yeah, we're definitely putting it, since we're just now bringing it up, we're going for dash 28.
Okay. I would be interested in trying to do the similar kinds of testing and seeing if we're able to duplicate results. If you could, will you be describing what you're doing on the Edisat mailing list also?
Yes, when we've been slowed down, of course, by everybody else since we're all working out of home. But yes,
Sure.
That is definitely what we were going to do.
So like I said, we're definitely interested in trying to participate in this also. So thank you.
Use empty? Yeah. Oh, Nico.
Hello, can you hear me?
Yes.
Okay, so this talk is in the same topic than the one that was addressed just now. It is just an update on the thing we had experience on what is a satellite path and what is the problem we have with Quick in this case. So I think you can go to the next slide. The next slide is the actual exact the same one than the one presented in the previous IETF meeting. The point here is saying that the satellite is very strange network, but it's just one part of the very stranger thing. So if you go to the next slide, basically, when we have end users using satellite accesses, we have, if we look at, we have first the internet on the left, which is a very high data rate and low latency and no losses. Then on the satellite ISP networks, we have a high data rate, but then now we have more congestion losses. The satellite access network on its own shows very variable data rate, no losses, unless you are on very heavy rain in India and some specific frequencies. But the latency is high here. And then on the local area network, we have an average data rate, but now we also have losses that can occur on a Wi-Fi link. So if you go to the next slide, when we have an end-to-end, for Earth, the subpaths that were mentioned in the vocabulary document are very important because we have here 4 subpasses with very different characteristics. But our reality with Quick is that our end-to-end is variable data rate, high latency, and congestion and Wi-Fi losses. So for these kind of things, it's very complex for us to see how we can actually have relevant end-to-end protocols when local breakout is not possible. We can first try to adapt the end-to-end protocol. That's what we have tried to be doing by experiencing to what extent Quick is actually showing good performances in these cases. Or another way to do it is to inform the endpoint of the path characteristics. So I think you can go to the next slide, or even I don't have lots of time. I made very wordy slides because I wasn't sure my audio or anything was working. So if you can go to these are basically the scenarios that we are considering in the drafts for synchronization for our tests between Aberdeen, Hughes, and others. So basically, what I will show here is some results. One is end-to-end without split, so it will be green. So we have been using PicoQuick servers or H2O servers, and then on the client side, we either have PicoQuick or curl. And we compare that with different flavors of PEP-SAL, which is an open source TCP proxy. And so we have IPERF servers and IPERF clients, and we have losses between the PEP-SAL and the client. So we have different configuration of PEP to see the problem we have been experiencing and to see to what extent we can tune the PEP though. I will not have time to go through all the results, but if you go to the next slide, basically this is a case where we have the same case that Gori showed earlier when we have 50 meg download and 10 megabits upload. What we can see here, so I always have this kind of representation. We have the received rate on the first figure, and the second figure is the received data. So we can see that I will not go through the different specifics of all the PEPs. I'm available if you want to discuss about these results afterwards. I have more details on to understand the results. But what we can see is when we tune the buffer sizes on our TCP proxies, we can reach the very high BDP. Otherwise, even the default TCP is not always able to reach the high BDP of the network. And these TCP proxies let us have some proposed objectives for the transmission time of different file sizes. So what we have done, if you go to the next slide, is looking what happens when we take a PicoQuick server and a PicoQuick client, or take an H2O server and a PicoQuick client, and vice versa. The idea was to see first what is the impact of what are the performances of when you choose one quick server version and another quick client. Because sometimes when we see evaluations of performances, we have the same flavor of different quick implementations. So we wanted to see how this impacts the end-to-end performances in these use cases. One of the first thing we can see on the figure on the left with Pico Quick Client is that we don't have any results for the 100 megabytes when we have H2O server and Pico Quick Client. And basically, we had a problem. We just take default versions of the different implementations, and we had too many retransmissions of one packet. So we had a disconnect. So here we can see that the fact that the Pico Quick server manages the maximum act delay and act delay component of the Pico Quick server better is very important. Another thing is when we compare the different Pico Quick always does better than H2O servers, and that's because it is using BBR. So we tried to see what happens when we choose Reno in Pico Quick, and we still had lots of much better performances. So the thing is, the evil is always in the details. We could see that at least some transport parameters are different, such as initial condition window, but it's not very different, and the initial RTT. So if you go to the next slide, here's another representation of when we see what happens. Basically, we see the amount of data received with Pico Quick Client and or curl client. What we can see here is that Pico Quick is the only one to actually meet the same performances as the one we have when we have a TCP proxy. The good thing is if you have Pico Quick Client and Pico Quick Server, then you can actually reach the performances of the TCP PEP and splitted approach of satellite networks. The next few slides are things I don't have time to go through, but they are here for your information. That are all the use cases, but I don't have time. So I think you can go to the slide 13. I am available if you want to discuss these results, but the main thing here that we know that we cannot deploy a congestion control that is relevant for all use cases. Knowing some path characteristics can help, because we've seen that by tuning the initial RTT or tuning some flow control parameters helped Pico Quick to actually reach and meet the performances on with TCP proxies. If you go to the next slide, the main thing is why Pico Quick meets the objectives. Basically, it's because it doesn't follow the standard. Here are a list of the different parameterization. You can see that one of the main differences is in the congestion control that is different between Pico Quick servers and H2O servers. And so we are actually working on to see what are the relevant parameters and what parameters are game changers. But to go back to what Gori presented earlier, if you go to the slide 15, another thing that Pico Quick does not as default today is the acknowledgement strategy, where basically, if you look at what we show here is the amount of data that is sent by the Quick client or the curl client. What we can see is that a Pico Quick client tends to actually increases very quickly the amount of data that is sent in the acknowledgement. So there is some strange coalescing algorithm in Pico Quick. Basically, the acknowledgement ratio is not constant throughout the whole communication. So these kind of things, I'm not really sure now, but this is to show that there are very important interactions between what could happen between a server and what could happen and a client. And the next slide is my last slide on what we are going to do next. So as I said, we are working on to see what are the actual relevant parameters for the satellite use cases. And we are going to implement the zero RTT draft that we have. So we want to see if there are some things that are implemented in PicoQuick that are relevant for everyone, and that should be included in the standard and not only for our specific satellite use case. And I think that the act management, as Gori showed, is one of the way to do that. Another thing we have is basically all that is related to the flow control. One of the things I didn't mention here is what very matters to us, and I think to the path aware network research group, is the management of sub-passes with very different characteristics. And when we have losses, this impacts a lot. So in Quick, we are working at the moment on adding coding in Quick, FEC in Quick, or Quick proxies, or all the approach that we can have to be adapted to that case. And also, we are at the moment have 2 implementations. We are working on making something quite flexible and making available to anyone to have some sort of fabric with which you could try easily any Quick implementation over different use cases. So we want to make all the code we have been using available. I'm sorry if I was quick, but I didn't have much time, and I'm here if you have any question.
We've got 2 at least. First, we have Spencer.
Well, not anymore. But my thing was just to be very, very brief and to thank you guys for bringing this information. All the people who are bringing satellite information in to PANRG, which is very important, and I think that's where a lot of the satellite stuff belongs right now. But thank you for doing that. I know not everybody's getting a lot of feedback, but you can hear our brains chugging out here if you get close. Thank you.
Thank you.
And Lucas?
Hello, can you hear me? Okay, great. Sorry for the background noise. I'll try to be quick. So just some clarification questions. I wondered if this was testing HTTP3, and if so, is this just a single resource transfer of a large file, which I think it might be? And then conjoined with that, you mentioned curl, but curl has 2 possible Quick backends. So I wondered which of those 2 you were using. Was it NGTCP2 or Quiche?
So thank you for the question. We have not been using H3 as far as I think, because we have just been using the default the code that was available for PicoQuick and Quick and H2O. So it was, I think, H2, not H3. And we have been using NGTCP2 in curl.
Okay, thank you.
And Jana.
Hi, thank you for this presentation. I had a couple of comments. First, can you go back to the slide that that compares the different implementations, H2O and PicoQuick? Yeah, that one. I think we just passed it.
Yeah. This one. Yeah.
No, not this one.
Slide 14.
14. Yeah. Okay.
That's the one. Thank you. So I just want to point out a couple of things that first, broadly speaking, it's not that PicoQuick is not following the spec. The spec requires a minimum of 1280 bytes. Doesn't limit how large you can send them. H2O right now matches whatever the client uses for the max packet size. So if you use an H2O server and a client that uses 1350 bytes, for example, then H2O server will use 1350 bytes. PicoQuick might be fixing it at a high value there. This is just an example of a difference in implementations that you're likely to see going forward. The question I would encourage you to consider is whether what the cost of doing these things is, Right? I mean, you can choose a maximum packet size that's 9,000 bytes if you want. The problem is going to be it won't work where you don't have a 9,000 byte NTU. So a lot of the implementations are making choices that allow them to work for most of the parts on the internet. And I would encourage you to think about how to make endpoints work well, given that they also have to work on other parts that are not satellite. The same holds true for the congestion controller as well. The point here is to try and understand whether I would suggest that you might want to look at what the congestion controllers are actually doing, and then consider how they would work on the public internet as well as on satellite networks. And there's just a broad comment. All of these evaluations are wonderful to see how these implementations perform. I'm happy to talk about the H2O implementation. It's moving rapidly. A lot of these implementations are moving quite rapidly, and I'd encourage you to look at when you publish these results, publish the particular commit that you're using for the code so that people know which commit you're looking at. I can tell you that from a past commit, performance would have been substantially worse than from a more recent commit of H2O. Just even a month ago would be quite different. So I would encourage you to keep looking at the performance and also keep publishing the date that you took the code or the commit number that you, the commit hash that you used for these servers. A final comment, in general, we don't expect, right now, the quick endpoints don't really have any way to communicate to the network anything, and the network doesn't have a way to communicate to the quick endpoints at their satellite networks. In all of these cases, I think it's useful and valuable to look at how endpoint behavior can be changed so that it works well for satellite networks and for other networks. I mean, whatever changes, if we simply tweak the endpoints to work really well for satellite networks, that's not going to be very useful, because as a deployment, I can't simply tune my server to use measures that are great for satellite networks, because I don't know when my traffic is going to go over one.
Thanks a lot. We also have John Porter. John, could you keep it to 30 seconds?
Can I try to answer, or maybe we wait for John answer and then we go back?
I was going to say, I agree with what John has said at the end there. I mean, I've always viewed it as the defaults can't be friendly in satellite. What you need is to be able to figure it out automatically. You can't require the end users to figure it out, to do it and tweak. So that's the key thing, is we need to have mechanisms to dynamically determine that that's the situation.
If I may, thank you for the comment. I just wanted to say that I understand the cost of deploying these things for the general use case. We just don't have I don't have the data for that. So I can share the data I have, and thank you for this. I know that increasing the buffer sizes everywhere can be costly on data centers. So we are actually also working on adapting endpoints, seeing what we can do on the endpoints. That's one of the things we will investigate. And for your comment on the commit version of the code, we will do that in the future, and also try to make our code, everything we do to orchestrate our tests. Everything is open source, but we just don't have made it public yet. So I want to make that public so that anyone can actually test also with different commits. And thank you very much for your comment.
And thank you, and thank you everyone for the questions. So moving on, back to John Porter.
John.
Okay, I wanted to put this together to just sort of get some new discussion going on another problem that we care about a lot, which is classifications. Next page, please. So I'm not going to read the Wikipedia thing, but basically, you know, classification largely depends on transport headers and application headers, and has traditionally done so. And, you know, port numbers being the primary things. Next page. For network operators, traffic classification is very important for meeting customer service expectations. Of course, my experience is satellite, but I believe this to be true elsewhere. Size and asymmetric paths. Also, the customer, you want to make the VoIP work, and even if somebody's doing uploads and that kind of thing. So it's really the key thing here is that from our perspective, the last mile is really the first mile, because the network where your user is connected is usually the one that needs the classification the most, because it's the last hop, and it probably is the constraining network. Besides prioritizing over the interactive traffic over background, for example, the device, such as the satellite terminal, actually may have multiple paths. So that's another thing. For example, if there is a LTE path and a satellite path, you want to be able to classify and decide which types to send which path. Because this second path is in the terminal, it's not visible to the end user, end device. So it's a little bit different than multipath when the multipath is all the way to the end device. Next page. Obviously, pervasive encryption is making this hard to do. That's a good thing, and we're not objecting to that at all. There's techniques like deep packet inspection, DNS correlation, SNI, etc. It still classify traffic when we can't see the headers. But unfortunately, anything we can do to classify, an attacker can do for other reasons. Page. So the question I'm trying to get discussion going on is, can the end user's device signal the network? And this is not the first time this question's come up. It's come up for many reasons. So that we can get classification information to that first mile device that it can use to get across the first network, but in such a way that then that information doesn't propagate farther than that and leak, or minimizes the amount of privacy information that it gives out. DSCPs are a natural option, but I think this is even in Spencer's document. There's the age-old problem of how do you trust the source? Although I think the world's changing, and maybe that question could be re-examined when the user's talking about his own traffic. Or an idea I've been playing around with but haven't had enough time to write the draft yet, is to use a mask-like technique to securely send metadata to just the first mile device to give it enough information to do that first level classification. Next page. Basically, this is what I was talking about on the bottom two pictures, is that case where I could either have a separate channel to the device from the end user that he could send me information about it, or it could just be an outer quick header that all it has extra in it is it lets me see the DSCPs or whatever, enough information to classify. Lots of work to have to go into making that happen, right? But that's kind of the idea. Next page. So, I wanted to get some discussion going on it. We really care about this problem. And we think it's going to become more and more important, especially when Quick starts really getting out there. And a key question, but not the only one, is how do you get the end user, or basically the client developers, to buy into this idea and provide ways for the end user to enable it. That's all I had. I'm hoping to just get some discussion going. Anybody have any questions or comments? Comments especially? Observations?
Corey, go ahead.
Yeah, I mean, but thanks, John. I haven't really read that one through before. This is an interesting proposal. Please read my draft in TSVWG on encryption and comment. I would love to join you in exploring this. I think this is an interesting problem where we can make some real inroads.
Your document was actually the one of the ones I was thinking of. This topic has actually definitely already come up before. But I was, in terms of I was trying to tie it in here, it's like, well, can we make the path aware of the classification is kind of the question, right? Without, just enough to make use of it as a part of the network where it's needed, and then drop it when it's for the rest of the network where you don't need it.
Do you need to drop it, John?
Well, I don't need to drop it, but I think some people might view that as privacy information. And it depends on how you signal it. I mean, that's part of it, right?
Yeah.
But I think like the thing that appeals about DSCPs is they're designed to be dropped at the edge of the network.
You could argue with my co-chair on that one.
Okay.
This is a great space, both with mask and without. I like both approaches. I think you should write a draft.
Okay. Yeah, that's the intent.
Cool. Spencer?
I agree that you should try to draft also. Please let me know if we can help. Brian, am I remembering that the evolving notion of trust is covered in the research questions draft?
It is alluded to. I wouldn't go out as far as to say that we have anything like an answer.
Oh, no. Well, that's the questions, right?
Yes. Yeah.
But basically, we're telling the research group that it should be okay to, it should be okay for us to be digging in a hole that's shaped
Absolutely.
like that.
Yep.
Cool. Thank you.
Colin.
Hi. I'm kind of wondering how much the state of the art in traffic classification has advanced, and whether it's now more feasible to verify if an endpoint is telling the truth when it's marking traffic than it used to be.
That's an interesting question. I'd have to think about that. I mean, for some types of classification, I think you probably could do a pretty good job, particularly, for example, if somebody claims to have the class of VoIP and is sending gigabytes of data, you pretty much can believe he's lying. That's certainly an interesting question to explore. Maybe you could get somewhere with that.
So I think Chris Wood might have an answer.
You might, maybe you're going to say the same thing. I don't know.
I think I was about to say the same thing, but you go ahead and say it first, and I'll see if I agree.
We can say it together.
Yeah.
No. So in the privacy enhancements in the PANRG group, there's a particular draft floating around that looks at traffic analysis and website fingerprinting in general, which is sort of this classification problem that you speak of, and it surveys basically the relevant research that we could find talking about how easy or not it is to do this in practice. Most of it is focused on things like Tor, flows like Tor, just because that's where privacy and anonymity is most important. But of course, the techniques also apply elsewhere. So I encourage you to go check that out if you're interested to know, what's been done in this space and how feasible it is. And of course, if you're interested in engaging with that group, I think they'd be more than keen to sort of help out.
Just to be clear, you said PANRG?
Yeah.
Okay.
Or PANRG, whatever you want to call it.
All right.
Okay. So yeah, I threw myself in the queue as well. One, to kind of point you in the direction of PANRG as well. I think there's also just I'm not as active in this space as I was, say, about 10 years ago, but I know that there was, if you look at at least the marketing in security traffic analysis, right? Like, so so enterprise systems for doing outbound sort of extrusion analysis as well as intrusion analysis. A lot of that marketing in the past 5 years has gone in the direction away from the direction of signature based traffic analysis, like basically saying this is a good packet versus this is a bad packet, or this is a good flow versus a bad flow based on matching like known malware characteristics, and has moved toward, I mean, all of it in the marketing is called AI, right? Like, so some of it might actually use machine learning and some of it might just use tweaked thresholds. But a key to a lot of this is behavioral analysis, right? Like, so actually looking at what the packets are doing, which is based on the understanding that, you know, the efficiency of a network is bounded by how much bandwidth you use for a given information exchange and how much latency you're willing to tolerate. So your traffic's going to push you very as close as it can possibly to the bottom of the bandwidth and latency consumption windows, and that basically means that the traffic is going to have certain characteristics just in the inter-arrival times. So I think there's a lot of people who don't show up here who are in that security space. Some of them are hiding behind marketing, which is marketing, and some of them might actually have traffic classification that would be more than good enough for the type of first mile signaling that would be here. So I don't know how to get them to engage here, or how to get them to engage with sort of like, you know, how can we use these technologies to make transport work without having to look at the payload. But I think there's definitely work that can be used in this space.
Okay, thank you.
Except as PRG.
Okay. The that also triggered a thought I forgot to bring up with Gory's presentation about ACTS, which ties in here, which is one of the concerns I've had, but I don't know how big of a concern it is that I hear people sometimes talking about padding ACTS to make them less obviously ACTS so that middle boxes won't delete them, which that's a good thing from a point of view of privacy, but it then aggravates the ACK asymmetry problem even more, and also then makes it hard potentially to do the pattern recognition. But anyway, I don't know how big of a concern that is, but it's something I've definitely thought about.
Chris.
Yeah, just to follow up on that point, I do think you're going to see more pushes in that direction in the future, in particular, actually making use of the padding mechanisms that were built into TLS 1.3 and into Quick and even HTTP3 and HTTP2. So I can't comment on like how painful it's going to make life for people, but it was likely going to happen.
Jonna. And I'll close the queues after this because we're out of time.
Okay, very quickly. I was going to second what Chris said. There's a lot of movement in that direction in general. And I think a lot of these classifiers that we're talking about also still use things that are exposed right now, such as SNI, to make a lot of conclusions about the traffic that they're seeing. And a lot of the push in general in the community is towards hiding that information as well. So going forward, while that classification might be effective now, the hope is that it's not as effective going into the future. My hope anyways.
That's kind of, and I understand why things are going that way, but then that makes my original problem harder, which is, okay, how do I be a good guy and do it?
Yeah, I mean, yeah, I completely agree with you. And I see that as a problem statement for the research group, broadly speaking, right? Yeah.
Okay, thanks.
Okay. Thanks. The last presentation for today.
Can you hear me clearly?
Yeah.
Thank you. Hello, this is Peng from China Mobile, and I'm glad to introduce my work on APN and some considerations about PAN. There are little same in the name and may have some connections or difference. That's why I want to have the presentation and explanation about it. I hope it will give some help or be valuable to our group. So I will introduce these two aspects. Next slide, please. Okay, first part is about APN6. The motivations of APN6 that new applications put forward higher requirements of network, and the network operators need to be able to provide fine granularity and even application level SLA guarantee to achieve better quality of experience for the users. For example, 5G and verticals generates more and more applications with diverse network requirements and revenue-producing apps such as online gaming, live video streaming, and much more demanding requirements. Nowadays, network operators are typically unaware of which applications are traversing their network, which is because network is decoupled from app. So they not able to provide fine and granularity traffic operations for specific applications. And there are no corresponding revenue increasing that might be enabled by differentiated service providers. And what APN wants is to add application knowledge to the network layer, which can enable finer granularity requirements of applications to be specified to the network operator. And as the IPv6 is being widely deployed, the programmability provided by them can be augmented by convene app info. Next slide, please. So the challenge of traditional differentiated service provisioning, we didn't do that because with IPv4 protocol, the packets are not able to carry enough information for indicating applications and expressing their service requirements. And the network device mainly rely on the 5 tuple of the packets of DPI. 5 tuples used for ACL matching of traffic are not the direct application information that not capable enough for new app added to. And the deep packet inspection may introduce CAPEX or OPEX and security issues. What's more, about the SDN-based solution, the controlling loop is too long to be suitable for fast service provisioning for critical applications, and there are need to be too many interfaces involved in the loop. Next slide, please. So according to those problems, how APN can help? APN 6 aims to satisfy the application awareness requirements demanded by new service and provide differentiated service treatment and fine grained traffic operations. It uses IPv6 or SRv6 network programmability to convene app info in the data plan, allowing the finer grained requirements from apps to be specified to the network. So it can convey the application information such as application identification and SLA service requirements. It also allows the network to quickly adapt the perform the necessary actions for the guarantees by SRv6 pass. So next slide, please. So the key elements of APN6 are application info conveying, app info and network capabilities matching, and network performance measurement. It should be noted in the element 1 that the application info conveying shouldn't be enforced by, but provide an open option for app to decide whether to input this app info into its data stream. If it opens, element 2 can be realized according to the info. the appropriate network service can be selected. And for the element 3, according to the measurement, it can update the match between the app and the corresponding network service for better fine granularity SLA complaints. Next slide, please. And we also have a framework of APN6. The key components include service-aware app, app-aware edge device, app-aware process head-end, and the midpoint and the endpoint. So for the service-aware app, it's a host obtains application characteristic information of the service-aware app and generates a packet which carries the application characteristic information in the encapsulation, but it is not mandatory to be service-aware. And the app-aware edge device, this network device receives packets from applications and obtains application character information. And if the application is not service where the application characteristic information can be retrieved by packet inspection and derived from service information. The app-aware edge device adds the app information in the encapsulation on behalf of the application. The packet carrying the app information will be sent to the app-aware process headend, and the app information will be used to determine the path between the headend and the endpoint for forwarding the packet. And for the app-aware process head and receives packets and obtains the app information. And the set of path tunnels or SR policy exists between the head-end and the endpoint. The head-end maintains a matching relationship between the app information and the path between the head-end and the endpoint. The head-end determines the path between the head-end and the endpoint according to the app information carried in the packets and the matching relationship with it. Next is the midpoint, provides the path service according to the path set up by the headend. The midpoint may also adjust the results locally to guarantee the service requirements depending on a specific policy and the application-aware information conveyed by the packet. And then finally, the process of the specific service path will end at the endpoint. The service requirements information can be removed at the endpoint together with the outer encapsulation or go to be conveyed with the packet. So in all this way, the network is aware of service requirements expressed by the applications. According to the service requirement information carried in the packet, the network is able to adjust its results fast in order to satisfy the requirement of the applications. So next slide, please. So there are some advantages of using IPv6 to support APN6 includes, and first is IP reachability. Then it is much easier to achieve since both app and the network are based on IPv6. And it can carry very rich information relevant to applications. If the application information not recognized, the packet will be forwarded based on pure IPv6. It is also little dependency because they are only based on forwarding plan of a device and it can quick response. Next slide, please. There are some use cases that can benefit from the application awareness introduced by APN6. including as a guarantee network slicing, deterministic networking, service function training, network measurement, and edge computing. And what I want to say is that edge computing is a new trend that might influence the network. It may be difficult to update all the operator's device, but may be more easily to change the edge device. So it may also benefit PAN. Okay, next slide, please. It's about security considerations because we expose some information about network. So accurate evaluation of security mechanism would be required in order to prevent any leak of critical information. And there are also some multi-domain problems need to be talked more. Okay, next slide, please. We had the SAN meeting in IETF 105 meetings and get a lot of support. And prepared to apply for the both in 108. So if you are interested in it, welcome to join. Next slide, please. Okay, I have read the draft of PAN and have some considerations of PAN and APM. But I'm not sure if all of them are right. So if it is mistaken, please point out. I think the same things of them is to provide better network and application service. They require the interaction between network and user or endpoint or application. But the difference is that PAN wants the endpoints or application to get path information and to select path. It works in layer 4 or layer 7. APM wants to endpoint or application tells requirement of network. It works in the layer 3. So next slide, please. And we can see some trends about network. Today's network is best effort, so customer won't expect too much of it. In most cases, they can tolerate its unreliability or instability, but network will be better than before. We can see that 5G of mobile network can give a low latency, high bandwidth, and multi-access connection. Some new trends like TS internet, computing in the network put forward high demand of network. And there is also a trend of network programmability, the interaction between network and user or endpoint, which is both APN and PN want. Although some protocols that are not feasible after analysis in the draft what not to do, we have the possibility to build or to give the direction of some new protocol or technique. And for example, the flow of IPv6, I think it is widely used in load sharing, and SIVP is an important protocol of TSN or .NET. Okay, next slide, please. And there are also some existing services that are a little similar with PAN. For example, when you want to download something, users can choose different servers, different network points, or different operators. When playing games, user may can choose different network points by themselves, or automatic service which will choose different paths by application itself. Though they are not in the same way of PAN, but some of the goals are the same. Okay, next slide, please. So the key problem, I think, are about the business and technology. The existing draft mentions that it causes a problem of who operates the network, endpoint, app, or operator. I worked in China Mobile and also have some discussion with my colleagues. There might be the chance of cooperation that a provider can rent a network's operation right from operator. Motivations may be that there are a few typical applications which account for most traffic may be care about SLA. If operator can really have some benefits from selling the controlling right, it can be done. But the difficulty is that it requires the development of device in operator's network and some new management about the new business, so which has also been mentioned in the existing draft. So for the technology, the draft 1.2 really gives a good analysis, and I think that it needs common exploration of multiple technologies by the new trend of the network. Okay, that's all for my presentation. Thanks. Any questions?
Wes. Wes, you are muted. Or possibly I can't hear you.
Neither can I.
Okay. WebEx thinks Wes is talking, but I can't hear anything from him. Do you want to put it in Jabber in the chat and we can relay? Any other questions first? Go ahead and start typing, Wes. Actually, I have to say that's the... Oh, go ahead, Spencer.
Yeah, while Wes is typing, I just wanted to thank you all for bringing the APN discussion here and contrasting it with what we're talking about usually with path-aware networking. That is thought-provoking. Thank you.
Okay, thanks.
Okay, so Wes's question is essentially, what sort of application IDs are you transmitting? Yeah, so what's in that application ID that goes to the sort of that middle segment of the network?
We may use IDs to represent what is the application and conveying in the
Right. What are the so Wes's question is, what are the semantics of that ID? Does it say this is web traffic versus video? This is video traffic, or what is the what are the semantics of that identification?
South of do you mean the south of the application itself, or
So I think it was like on slide. Could you go back a few slides? I forget the slide number. There was a picture. Keep going.
This one?
Yeah, this one. So the APN6 framework, right? Like, so there's some information from the app-aware edge that gets put into the app-aware process head end and endpoint. So there's some application ID. So what are the semantics of that application ID?
okay.
So the point is from Wes is that, like, if you're actually saying, well, this is web traffic, or this is traffic of a particular app, right? Like, so a particular app on the phone, then that has a certain set of privacy characteristics that are I think quantitatively worse than the privacy characteristics of saying what the network requirements are. Like, so in terms of like what the bandwidth is, or what the transmission, sort of like what the shape of the bin you're trying to pack in the network is. Colin also makes the point, many applications send different types of traffic. So if you have a application ID that is assuming that the application is, for a given path in a given time frame, going to have heterogeneous traffic behavior, that might not be enough to actually classify to pack the bins.
Yeah, I think the idea is just to present a number of it, and to really will come some information about the network requirement, like
okay.
the
So it is in terms of like how much bandwidth and what the timing looks like. Okay. Cool. Other questions? We're a couple of minutes over, but like nobody's kicking us out of the room.
Thank you for relaying, Brian.
Oh, there's Wes. Now it works. I was going to say, it was like, this is pretty amazing. This is the first time I've done 2.5 hours in WebEx where we got to the very end before anybody had any audio problems. So
I'm glad I could help with that.
Thanks much.
I ended up switching to landline. So I think I have
Okay. Yeah, I see you've got the, following the directions at the beginning. Cool. All right.
You
Other
summarized
questions?
my point perfectly, which is that, that asking for what you need out of a network is generally much more privacy preserving than saying, I am X, please help me.
Yep. Other questions or comments? Cool. All right. Thanks a lot for bringing this to us.
Yeah, thank you. And just a reminder, if you have not done so, please sign up in the virtual blue sheet, and the link is on the slides or in the agenda. Please put your name and affiliations there so we know you've been here and listening. So I guess that's it for today. Right. Thank you very much, and I guess see you in.
Good job. Thank you all.
Thanks a lot. We'll see you online.
Yeah.
Good night / good morning, everyone.